Share screen. All right. So, okay. So please don't hesitate to interrupt me if I'm going too fast or if you have any questions. I'm going to try to be as thorough as I can, but I'm sure I can miss things or explain things a bit too fast. So don't hesitate to interrupt me. So okay, so I'm going to do this presentation from the point of view of Backend Engineer. What, like, how the logging page works, where is the code, how to troubleshoot if there's an error, and also some things to keep in mind while you're working on logging code. So okay, so let me start with the legacy mode, which is the mode that doesn't use Elasticsearch. So if you have a cluster where Elasticsearch is not installed, this is the UI that you're going to get. So we're going to go and query the Kubernetes API for the logs. And so this API is very limited in the filtering you can do and the querying you can do. So the only option you have is selecting the pod. So when you do anything in the UI, so first, the first query that is done by this page is to get the list of environments. And so this is what's going to be displayed here. And there's a number of settings related to logs in the environment's response. The most important being where if the environment has enabled advanced log querying. And so this tells you that if it's true, then Elasticsearch is installed in the environment. If it's false, then it's a legacy environment that uses the Kubernetes API. And so this changes where in the backend the log query is done. For example, I have two clusters here. One is my production cluster where I have Elasticsearch installed. The other one is staging cluster where Elasticsearch is not installed. So this is the first request that the UI does to the backend. The second one is actually getting the logs. So for the Kubernetes endpoint, so this happens when you're in a legacy mode, you can filter with, you can give it a container name and a pod name. So that's two only allowed parameters for the Kubernetes API. If you go to the, let me show you the production one first, and then I'll go into the controller code. So on the production interface, you have much more filtering. So you can see here that the request, elasticsearch.json, contains multiple parameters. So the first one is, as the previous one, container name and pod name. And so there is a special case here where if both are null, then it will get logs from all the pods. So this means that this search bar is empty. And if you filter by a pod, then this gets populated. We still don't support container name filtering at the moment, so it stays null. The second parameter is the cursor, and this is used for pagination. I'll show in the service how pagination works. But basically, when you scroll up, it will do more requests using this cursor. There's basically a point where it basically is the last log that has been displayed, and it tells the backend to query after this point. And then the last one is time filtering. So you can customize the time range of your requests. And this goes, it's not actually showed here, it goes in the path, where you can kind of see it here, start time and end time. Okay, so that's the two requests, basically KLS.json and Elasticsearch.json, that are handled by the code on the backend. So let me jump to the podlogs controller. ops control. Okay. So there's two endpoints, KDAS, Kubernetes and Elasticsearch, which are rendered by the same method here. And so it's basically a way to say that there's two services with an identical API that handle either the Kubernetes case or the Elasticsearch case with varying parameters. So you can see that in the Kubernetes case, we only support container name and pod name, and for Elasticsearch we add search, which is like full text search, which I didn't show actually. But you can do, for example, I mean, it's not going to be really good with this because all the logs are the same, but you could, for example, find a log using full text search. So that's this one, start time, end time, and cursor we mentioned already. So there's the two services. So the two services have the same API. They originate from the same base class, which is Podlog's base service. And this is a reactive cached service, which what that means is all the computation here is going to be handled by a sidekick worker. So I actually had it disabled, and I'm going to tell you why in a second. But if you don't disable it, this request is going to first enqueue a sidekick worker. This worker will run in the background and put the result of the computation in Redis. And then the front end will poll every second until that result appears in Redis. And we use this because requests to the Kubernetes API or Elasticsearch, which go through the Kubernetes API, are really slow, and so we don't want to risk denial of service attack on GitLab.com. But when you're working on logging, I really strongly suggest that you disable reactive cache. The reason for that is sidekick workers locally have a tendency to get stuck, and that happens every time. That can happen every time you make a change and the code has to reload. There's some issue with code reloading in Rails that can make the workers be stuck on your machine. And so often you will try to make requests and see that the result don't appear in Redis, and that's because your sidekick is stuck. And so I always work without reactive cache, only when I really want to check for, before publishing an MR, I check my work with reactive cache to make sure it works, but day to day you should really disable it. So when the controller calls the service, this enqueues the sidekick worker, and then the sidekick worker executes this method here. And what it does is it calls execute steps, and that's from the steppable module. And so it allows you to execute a service like method by method, and you're going to see this so in the child class in Kubernetes service, where we define a list of steps. And so that's each of these is going to be executed one after the other, and so it's basically going to progressively enhance like the results of the computation. It's a way to really isolate like single purpose methods and have a code that's clearer to read. I'm not sure about the level of detail I should go on each of the steps. It's basically going to do input validation, get if some of the arguments are not filled, it's going to get them from the Kubernetes API. And then once it has all the arguments, pod name, container name, it's going to query qclient, which is going to call out to the customer's Kubernetes cluster, and then return the logs. And then we do some post-processing, encoding, and formatting of the logs. So that's the Kubernetes case. On the Elasticsearch case, so it's the same API. It's also using stepl, but the steps are a bit different. We have additional arguments to check. So here you can see it verifies that the times are formatted correctly, the search is valid, and the cursor is valid. And then it gets the list of pods from Elasticsearch. And it also queries Elasticsearch for the logs. And so that's in another service. What's interesting here is backwards compatibility. So when you're working on logs, you have to keep in mind that there were historically multiple versions of the Elasticsearch application. And we just recently migrated from Elasticsearch in FileBeat 6 to Elasticsearch in FileBeat 7. And so we have customers in the wild that haven't upgraded their Elastic installation and that are still querying Elasticsearch 6. And we also have new installations that have Elasticsearch 7. So any feature that you build on Elasticsearch has to keep in mind that it should be able to query both of those versions and also any version that we publish in the future. So there's some, you'll see in some parts of the code like checks like this that verifies if we're above a certain version and that changed the type of the query that is done. So that's really something to keep in mind. Because I don't really think any user that was using logs before we pushed the upgrade has been upgrading, because the upgrade button is really hidden in the UI, and I don't think a lot of users know about it. So there's probably a majority of legacy versions rather than new versions. So that's for the services. Do you have any questions at this point?
I was wondering, how do you test for backwards compatibility?
Okay, so that one is a bit, that's a really good question. I didn't think of preparing something for that. So testing for backwards compatibility, there's basically two options. One is you keep a cluster that you don't upgrade, which can be costly because you should maintain like 2 or 3 different versions, I think, of the Elasticstack application. The other one is, and that's the one I'm doing, is you have to downgrade your GDK. And so, for example, go back to GitLab 12.7 or something. I don't remember the exact versions. And run your JDK at that version, do the install at that version so that the Elasticstack application is installed with like the legacy version, and then go back to your branch and validate that the code works with that old version. That's kind of what I've been doing. I think it's not really very efficient. We've only had recently updated versions where you needed that backwards compatibility. So I think that's something we could definitely work on for testing, having the ability to install legacy versions easily.
Yeah. So until we have something like that, I've never actually tried going back, changing your local GitLab version, GDK version to like 12.7, 12.6. Does it work easily? Like, do you have to worry about TV migrations or anything?
Yeah, there's a couple of manual steps. The first one is reverting the migrations. You don't, I'm trying to remember, last time I did that, I don't think I really had to revert, because we're using a very small part of GitLab, and so most of the migrations don't really apply to us. when testing this functionality. I guess it's going to depend on the kind of migrations that happened in between different versions. You could have to revert the migrations, which is a bit hard because if you check out the old version, then you don't have the new migrations to revert. You have to revert them using master. So, or you could just like wipe your database and restart, which could work if that's something you want to do. But it's really not efficient. I spent a lot of time reverting and fixing this kind of issues. There's another one that I've run into, which is something to do with the Helm version. And I'm blanking now on where this is defined. Here. So at some point I had to downgrade this version as well, because the old version of GitLab was using, I don't know, 2.15.7 when you check it out, and your cluster is already upgraded to 2.16. And so you have to go and manually change this version to say 2.16 in the legacy GitLab version. So it's really a lot of manual trial and error. Yeah, that's definitely one you have to do, the Helm version.
Cool, thanks.
Okay, so I'll talk a bit more about installing and uninstalling and Helm afterwards. First, I want to go to the query. So we have two query objects for logs. The first one is pods, and this basically populates this dropdown here. In the Kubernetes API case, you get it directly for Kubernetes, but the problem is it only returns pods that are currently running. And so by querying Elasticsearch for the same data, we can get all the pods that were running in the cluster during the last 30 days, and so which have logs you can query on. And so this goes through this query object, where you have like this Elasticsearch query. I'm not going to go in detail into the Elasticsearch queries. I think documentation on this is pretty good, and it's kind of tedious to explain. But this basically does a query for all the pods that Elasticsearch has seen, and then returns it in an array. And then the second one is lines, and so this is getting the contents of the logs based on the arguments. So I'm not sure it's not working, but if I go back to the response, that's the two items. So pods is going to be the pods query, and then logs is going to be the lines query, where you have all the log lines basically with the timestamp. And so there's a number of filtering based on the parameters. There's pagination here, which uses the cursor. Where is it? Yes, search after. And so this basically tells Elasticsearch to only return results after the cursor that it returns. And the cursor is those two fields. And so it's basically greater than this timestamp query for pagination. There's a number of filters depending on the parameters, and formatting of the response, and then that's basically it. So it's pretty simple. Any question on Elasticsearch querying, how this works, or? Okay, so I will go to the app itself. So this happens in the Kubernetes page in the products. So as you can see here, I have my 2 clusters, one with Elasticsearch installed, one without installed. You could create any number of environments to maintain like legacy cluster, for example. I think that could work and be more efficient in the long run. Maybe we could maintain more clusters, for example, in staging GitLab to validate MRs. I don't know. But if you go to the applications page, there is Elasticstack. And so as you can see in this cluster, it's already installed. I'm going to go to my other cluster and install it to see how it works. Okay, so when I click on install, it's going to, so I'm going to show this in detail, but the gist of it is it calls a scikit worker that is install cluster application, something, cluster application. I should have looked this up first. App install worker, I'm not sure. So here I have the uninstall worker, and so never mind. Well, we'll see it when I do the install. I just do GTK. Where's my jobs? So it's going to call a scikit worker, and this worker is going to call out to the Kubernetes cluster and launch a container that will install Elasticsearch. So let me just connect to my cluster here so I can show the pods. There you go. All right, so you can see all the pods. In GitLab Managed Apps, we don't have anything. We have Tiller, which is going to be doing the install, and that's a dependency of Elasticstack, but there's nothing else. So when I click on install here, so it's going to call the scikit worker, and then this is going to launch a container in the cluster that's going to do some Helm install commands. So let's start this. So of course, I think my scikit is stuck. So this is something that you always have to do, which is restart scikit. It's good because I'm showing also like what goes wrong. Because now I have restarted scikit because it was stuck. I'm not sure if my job is still in the queue. Yeah, that's the cron jobs that usually make it fail. So I don't have anything in the queue. That was before, so I can just delete that. Let me retry. Okay, so now the problem is in the database I have an entry for this app that says it's installing, but my scikit job is not processing. So the way to fix that is to go in the console. And cluster applications Elasticstack. Only, well, so I'm going to delete the last one that it created. And so this is going to reset this button. and so I can install it again. So if you get stuck with the state machine here, so there's multiple states: install, installing, updating, deleted, and so the buttons can sometimes have get stuck. You can just delete the database entry basically, and so this will reset the cluster. So just to be sure, I still don't have anything running. So we can start again. So my sidekick has been restarted, and so now it should be doing something. That was another one to do, sorry. Let's start again. Okay, so it's cluster install app worker. That's running. And so this is going to start a container that's called install Elasticstack in your cluster. And you can look at the logs using this command. So for now, it's still creating, so we have to retry. Yes, and so here you're going to see the process for installing the application. And it's basically just a container running in the cluster that's going to call out to Helm. And we're going to be able to see that working. Usually works faster than this. Is Kubernetes charged down right on my demo? It's saying something, so that should work. Yeah. Okay, I'm going to do this the other way around. I'm going to reconnect to my other cluster. Demo effect. And I'm going to go and first uninstall it, which is basically the same process. Instead of doing a Helm install, it's going to do Helm delete. The only thing you have to keep in mind, if you uninstall Elasticstack, all your data is deleted. So let's see the uninstall logs. All right, so now it's working. So, okay, so it's configuring Helm, and then it's doing Helm delete, purge. And so this is going to delete all the Elasticsearch pods and services and all that stuff. And then this actually deletes the data volumes. So all the Elasticstack indexes are going to be deleted. And once that is done, the front end is polling, and then it detects that it has been uninstalled, and then it resets this part here. So when I do install again, hopefully now it will work. Yes, perfect. So it's going to be adding the repository that we have for the chart. It's our own, we maintain our own Elasticstack chart since a couple of months ago because the official ones have been deprecated. So we need to add that custom repo to Helm. And then this is the installation. So it's just Helm upgrade. It's not really an upgrade, it's install Elasticstack using these parameters. And so there's two things that are interesting here. So the first one is the values. So this is actually the settings that our chart is using. And so it's configuring Elasticsearch and FileBeat, disabling Kibana, because we don't want to release Kibana, and then configuring Curator. And Curator is a service that every day will delete the old indexes. Anything older than 30 days is going to be deleted by a Curator. And so that's a front job, basically, that's running every day to keep the number of data that we maintain low, and so we don't run out of space on the cluster. On the FileBeat configuration side, this is just saying get all the logs from the containers running on the host. So that's all the paths basically. And then add metadata from Kubernetes, from GCP, and decode JSON fields. And that's another thing that's interesting. We have another team that is using the Elastic Stack for their purposes. And it's there's one of the secure teams, I'm blanking on the name, that are using Elasticstack to parse logs from the web application firewall application. So any update that you do that could potentially break their side of the product, you probably have to synchronize with them. It's something that we noticed only recently, I think a month or two ago. And so, yeah, so keep that in mind if you're doing any changes to Elasticsearch or the configuration. We have other teams using that service. Okay, so this is just configuring the charts, and so the actual chart lives in Elasticstack here. So under the GitLab org charts.elasticstack, this is where we have our own compilation of charts. It's basically just using the official Elasticsearch stack from Elastic, the official Kibana stack, and the official Elastic FileBeat chart, and then Curator, which is using the legacy official repository. At some point, we should think of moving away from Curator because that functionality actually exists now in Elasticsearch 7. Which we weren't using before, so we haven't yet migrated to it. But you can do index exploration now with Elasticsearch 7, so you don't really need that anymore. And that's just what this repo is about. It's just saying, like, there's nothing really custom here. It's just, okay, these are there's some default values. So these are the charts with the versions that we are deploying. And then it's configured using the values in the GitLab repo. So you would only have to make a change here if you wanted to upgrade, for example, the Elasticsearch version. And then I think my last point here is this file. This is the version of the chart. It's also the version that is stored in the database. So when you want to upgrade the chart, you first have to tag a release here. So you can see we have a number of tags. V3, for example, is the last one. Then when you install the app, this is the version that it's going to query, and it's going to be stored in the database. And so this is how it detects that what you have in the database is not up to date, and you could upgrade. And then that's just some stuff to install and uninstall. What's interesting? Here we have some of the compatibility items that we have to do. Starting with V3, like the names are not the same because that's actually when we introduced our own custom chart. Before that, we were using the official one. So some of the names have changed, and so this is where it happens. And this is the migration script if you don't, if you're now using v3, then when you upgrade, it will remove all the data in the cluster and start fresh. That's basically what this is saying. Okay, let me just look at my notes to see if there's anything I missed. Legacy active cache. Yeah, I think that was all I had to say. Any questions?
Yeah, thanks, Edwin, for this introduction. Could you mention, please, for the future record, what are the resource requirements for installing Elasticstack? Because it's not so obvious at the beginning, and I bumped onto not enough resources in the past, so it would be nice to have this included in this presentation.
Yeah. Also, I'm sorry, I just saw the time, so I think we're over my scheduled time, so sorry about that. Yes, so the requirements for the Elasticsearch install are a bit high. Let me find that page. It's blank. It's applications, MD, something like that. Applications. So if you look at the documentation, it's where does this live? Here. So yeah, so just for the record. So okay, so the Elasticstack chart that we use, it needs at least 3 nodes in the cluster. And so this is because we're using a high availability mode of Elasticsearch where it's a cluster of 3 nodes. And each of those 3 nodes need to have enough CPU and memory to be able to host Elasticsearch. And so that's 1 CPU and 2 gigs of RAM. That's the default settings. We could probably reduce this or introduce maybe a development mode that you could activate if you're only running on Minikube, for example. That's something we could think about, because right now you can't use Minikube to deploy Elasticsearch. You have to have like a real kind of big cluster in GCP, and that can be costly, especially for development. And the real issue with that is we currently don't check at all if you have the resources to install Elasticsearch when you click on the button. And so if you click on the button without having the necessary resources, then this step here is going to time out. And so when that happens, you're in an inconsistent state where the cluster installation has failed. But as you saw before, my database entry is still saying installing. And so you have to delete this and then restart the install. And so that's not something that customers can really know to do. And so we really should be doing something about that, I think. So yeah, that's the, I mean, anyone that's starting to use Elasticsearch has hit this issue because everyone just starts with small clusters, which is normal. You want to keep costs down, but it's something that everyone really is hitting, and so we should probably be fixing that. Yeah. Any other question?
Do you have like a contact for that other team which also uses Elasticsearch?
So there's an issue for that. Let me find that. There you go. So that's the one, and it's the container security group. So there's some discussion here, like just people being aware of this. I'm going to paste this, I guess, in the chat. I'll do that again. Chat. There you go. So from this issue, you'll be able to see which are the people that we need to be talking to, and then I guess just reach out to them.
So the only repos that we need to know are the GitLab.com, GitLab-or, charts, Elasticstack. And is there anything in charts.gitlab.io?
So how this works is let's extract account. Okay, so when you tag a release on this repo, there's CI pipeline that runs only on tags, so you have to actually tag a release, and this does the release table job, and so this is going to trigger a pipeline on the charts repository. Here. And so the trigger for this is going to like get the new chart and then publish it in the repository. And so I think this is hosted using GitLab Pages or something. And so this is what the trigger does. It just like gets the update and then republishes the GitLab page. So to be able to release a new version, you have to tag a version here, and then it's done. You may need to have permissions to do it. I think for charts.gitlab.io, if you just tag a release and you don't have permissions there, it fails. Something like that. There's some permissions things to figure out, but that's the process.
Cool.
All right.
If no one has, I just had one last one.
Sure. Go ahead.
About I remember we used to talk about an issue to allow Elasticsearch to have the logs for all pods, not just in the GitLab managed apps namespace. I don't remember what is the path that we talked about to achieve that.
Sure. So that issue is, I have it in my intro. Okay, so let me find that.
I think this is the one I pasted in the chart, in the chat.
Oh, sorry, I didn't see that. Thanks. Yes, that's the one. Okay, so yes, so it's all here. So the plan for this. So okay, so there's the issue with implementing this is right now. If you go to operations, where am I? Oh, I'm in the admin. What am I doing? There you go. Okay, so if you go here, the only thing that you have is different environments. And so if you look at a cluster, an environment is a Kubernetes namespace. So the idea was to also display an entry here for GitLab managed apps. And so that's another namespace, which is kind of similar to an environment. So it kind of does the same purpose as here. There's only one GitLab managed apps per cluster. And so the idea was to, instead of repeating the name of that namespace, do a second section with each cluster that you have access to. And you have to be mindful of access here, because on GitLab, you can have a project level cluster where you need to be a maintainer of the project to access it. You can also have a group level cluster where you need to be a maintainer of the group, and which doesn't necessarily map to a project maintainer. And you also have cluster level, instance level clusters, where a cluster is configured for a whole GitLab instance, and then to access that, you need to be an admin. And so there's some access control that needs to happen here. But once we're able to do that access control, then it will work identically to environments, because this is actually already a namespace. So the only thing that needs to change is, instead of saying environment name in the parameters here, you need to be saying like the cluster and the namespace you want to query. And so this is going to let you query for any namespace in the cluster, and especially GitLab managed apps.
Thanks.
All right. Any last question?
No, thanks for putting this all together and walking us through this. Be super valuable. And yeah, we can work to figure out where to put this recording, but yeah, we'll have to make sure we save it somewhere. We can find it.
I'll post it to Unfiltered, I think, right after this.
Perfect.
So you have it and you can access it in the future. If you have any questions with how all this works, I'm just going to another team, so I'm still going to be here, still going to be available to answer questions. So don't hesitate to reach out, and I'll be happy to help. All right. Well,
all right. Thanks,
Adrian. I guess I'll see you then.
Thanks.
Thanks.
Bye-bye.